All right, so picking up where we left off, we were talking about polyatomic ions and their usefulness in making ionic compounds. You'll see these a lot, and so it's good for you to go ahead and familiarize yourself with them. Don't worry about memorizing all of these. I'll give you a list of useful ones to have memorized so that you will be more prepared when you're looking at a question on a test and not be confused by what you're seeing. Okay, but in general, each of these is an ion made up of multiple atoms, and usually it's some nonmetal with oxygens attached to it. A couple of them are transition metals with oxygens attached to them, like the ones in the bottom right: chromate, dichromate, and permanganate. There's only one, I believe, on here that has a positive charge, and that is ammonium. You'll see that in the top right, and it's a little different because it's nitrogen with 4 hydrogens, so that one's a little bit weird. But most of these have names that end in ate or ite. There are a few like cyanide, peroxide, hydroxide. A few of them still end in ide, but they don't have an element name from the periodic table, so that should hopefully help you remember a little bit better that those are not just an element. Okay, so ate versus ite. I want us to talk about the difference. Ate implies that there are more oxygens than ite, and ate usually has one more oxygen than ite of the same nonmetal. So what I'm trying to say is, let's look at chlorate and chlorite. They're in the bottom. Chlorate has 3 oxygens. So chlorate is ClO3, and it has a -1 charge. Okay, chlorite has 1 less oxygen than chlorate, so chlorite is ClO2, and it also has a -1 charge. There are a couple others that are a little bit different because it could have a prefix as well. And so chlorate is a really good example because it could have even more oxygens. It could have 1 more than the chlorate, and that would be called perchlorate, and that has the prefix per, and that would have 4 oxygens. Sorry, I'm writing this weird. ClO4, I think it's still a -1 charge. Okay. Now, if it has even 1 less oxygen than chlorite, it would be hypochlorite, and that's all the way on the bottom left corner of the picture here. Hypochlorite, and that's ClO with a -1 charge. Okay, so all of these here have the same charge. It's not always going to be true, but they have different numbers of oxygens, and that changes the suffix, and in some cases the prefix. Okay, but the most common are the ones that end in ate and ite. Alright, so here are the ones that you really should memorize, and actually I forgot to add one to this list. Let me edit that real quick. You should also memorize hydroxide. So, sulfate, just like it sounds, has a sulfur ion, and the formula for sulfate is actually SO4, and then it has a 2- charge. Okay, sulfate is extremely common. I recommend with these ones you kind of look at each of them every day and kind of make sure you can remember what they are. Carbonate is also extremely common, like if you think about carbonated beverages. It's CO3 with a 2- charge. Acetate you would find in a sample of vinegar. It comes from acetic acid. Acetate is C2H3O2, and it has a -1 charge. Another way you can write the same compound is You know what? Ignore that. It's simpler to just remember one formula, but you might see it written a little differently where it ends with HOOH. I think it's CH3COOH. Yeah, sorry. Got to do this a few times. CH2COOH. Yeah, this is the other way you would see it written. This is because of the way that the structure of this covalent part of the molecule is. Sometimes you'll see it written like this. But really, this is the same thing as this because it still has 2 carbons, 3 hydrogens, and 2 oxygens. Okay. Next is phosphate, which you could guess that probably has phosphorus, and you would be right. PO4. Now, this is the biggest charge you're going to see, a -3 charge. Phosphate is extremely common in biology. If you think of phospholipids and all of that, phosphates are so common in biology. That's why that's a really good one to memorize. Ammonium, we already said, is the positively charged one, and so that one might throw you off sometimes if you don't memorize it. It's NH4 with a +1 charge. Okay, so remember, positive charges are always written in ionic compounds first, so this is an example of one where you write NH4Cl, for example. Okay? And finally, hydroxide kind of combines the beginning of hydrogen with oxide for oxygen, and this is actually OH -1 charge. This is extremely common in bases that we'll be using in class, like acids, bases, because this is a very strong base. Okay, so you'll also see hydroxide quite frequently. These are all the ones that I would like for you to have memorized. All right, so just an overview really quickly. If we are naming a normal ionic compound with main group metals, you can get the charges of the ions using the periodic table. You can balance their charges to write their formula. So, like we've seen several times, chlorine you would find on the periodic table has a -1 charge. Sodium you would find on the periodic table has a +1 charge. Using the crisscross method, we can figure out quite easily that we need 1 chlorine because of the +1 charge of sodium, and 1 sodium because of the -1 charge of chlorine. So it would be Na, positive thing first, Cl. Okay? With transition metals, you can find their ion charges usually in the name. So if I had the name manganese to chloride, I'll keep with my chloride here, that way it's easy to remember. That would be a 2+ charge on my manganese. Remember that Roman numeral tells you the charge. So Mn for manganese +2, and Cl we know has a -1 charge. So crisscross here, we have MnCl2. Finally, we get to polyatomics. So the ion charges for polyatomics you would look up on the back of your periodic table. So let's say I told you to write the formula for magnesium chlorate. If you recall from the previous thing we were discussing, chlorate has one more oxygen than chlorite, and that was ClO3, and it had a -1 charge. You could look at the back of your periodic table and find chlorate. It would be with this formula. Magnesium has a +2 charge. So if we wanted to write a formula with these two, we have to do the crisscross. We're going to have 1 magnesium, but we're going to have 2 chlorates. That means we need to put it in parentheses. Don't forget to put it in parentheses. So ClO3, that's the whole polyatomic ion, but we need 2 of the polyatomic ions, so that 2 is going to go outside the parentheses. And it's kind of like 2 is multiplied by everything inside the parentheses. Okay. And finally, reviewing naming for each of these. When we have a main group metal or a normal binary ionic compound, you will find the elements of the periodic table. write the name of the metal, because the metal's name never changes. The metal's name goes first, and then end the name of the nonmetal in "ide." So if I had this formula, let's see. If I had BaO, I would look these up, and I would find that this metal is barium, and this nonmetal is oxygen, so the ending changes to "ide," so it becomes oxide, barium oxide. With transition metals, we have to find the charge of the metal by looking at the compound. We have to write the name of the compound, but we make sure to put the Roman numeral to represent the charge, not the number of atoms. Okay, so let's say I had using the reverse crisscross, we know that the plus charge of Fe must be +2. All right, and that chlorine is always -1. Okay, if we have 1 iron, then that would be -1. But also we can look at the periodic table and see that chlorine has a -1 charge. Okay, so when I write the name of this, this must be iron. Oops, got my arm. Iron chloride, but then in the middle goes the Roman numeral, and that Roman numeral has to represent the charge of the iron, so it has to be iron 2 chloride. Finally, we get to polyatomics. You would find the name of the polyatomic ion on the back of your periodic table by looking at the formulas. Then you can write the name of the cation, and then write the name of the anion. Remember, cations are positive, anions are negative. So, if I had, for example, let's see, CaSO3. Once you see the metal, you know metals are usually ions, so you can assume this other part must be a polyatomic ion to balance the charge of the metal. Now, this polyatomic ion you would look up on the back of your periodic table, and you would find that it's sulfite. This calcium, you know the name of it from the periodic table. It's just calcium, so the name of this compound is calcium sulfite. My cation is first, and then my anion, just like it is in the formula. Cation first, then anion. Okay, and this is a review of naming all of the different types of ionic compounds. And that's all we have for today.